that UPSC has deviated its strategy from whatever it used to do earlier. So earlier, UPSC used to ask questions from almost all the topics. At least they tried to ask. Like they used to ask the questions from blood relations, direction, routes and networks, like the topics of logical reasoning. And also from the quant, like profit and loss, percentage, and all these topics. But this time what UPSC did, they shifted their focus majorly on two topics. That too of quant. And those two topics are generally considered as difficult by students. So now our strategy of studying only simple topics cannot work anymore. So in that case, we need to study, we need to read all the topics that are there in CSAT. Whether they are the topics of LR or quant or any other thing. So, and quant will play a very major role in the upcoming exams also. UPSC has given us has shown us that trailer. And if you will ask my genuine opinion, then the paper was not difficult. Paper was not difficult. Paper was difficult in the given time period, because you went to the examination hall with a set mindset that okay, what I'll do RC first, and I'll do these blood relation questions, I'll do direction, routes and network question, and then at the end I'll try some difficult questions. But when you entered the examination hall, you saw the paper and all your strategy went into vain. You saw there are 22, 24 questions from the number system and permutation combination probability. Then what to do? So now, as UPSC changed its question setting strategy, we need to change our approach to tackle that strategy. So quant will play a very important role, as I said earlier. I have seen many students, I have met many students, those who face difficulty even in very basic concepts in the quant, like subtraction, fractions, decimals, factorization. So to cater the needs of those people, those who cannot give time to read the class books of class 6, 7, 8, we are going to cover this topic where we will cover the very basic things which will build your foundation, and then you can build your building, a very strong building over that very strong foundation. So be very aware while watching these lectures. Try to practice and try to get a command over these things, simple basic things, subtraction, factorization, and all these things. That will give you an edge over other aspirants who are directly going to read the topics or directly going to attempt the questions. Okay. So first, this quant is very easy, extremely simple, and I genuinely hope that I'll try my best, whatever is there in this lecture, and you'll feel very comfortable. Just watch very seriously and try to attempt as many questions as there. And I hope you all have gotten that handout with you, so you can attempt the questions also. I will not attempt all the questions. I will just give you. I'll try to show you a path, and then you can attempt. And we are always there to help you out. So today we will be studying this numbers, fractions, integers, decimals, word mass. So what is fraction and what is integer? So I will not tell you any bookish definition. Whatever will be needed for our exam, because our goal is not to get 150 in CSAT. Our goal is to comfortably qualify CSAT. So I will tell you the things which are required, not any bookish definition or the definition that you need to remember. This is not a subject of history or geography or sociology or anthropology where you need to remember. So fractions, anything, let's say 3 by 4. Anything which is written in the form of A by B is a fraction. 3 by 4, 5 by 6, 7 by 8, All these things are fraction because they can be written in the form of a and b. If it is written 8 by 8, is it a fraction? No, it is completely it is equal to 1. This is an integer, so this is not a fraction. Then integers. Integers are the general numbers, what we study. But there should not be any fraction, no decimal. 1, 2, 3. All this is integer. Decimals everybody know. If I write 0.5, it is a decimal. 1.25 decimal. 1.8 decimal. All these things where we use the decimal point, it is decimal. What mass we will study later. Also, I want to tell you there are certain things. One is natural number and one is whole number. Whole number is we count 0, 0, 1, 2, 3. All this is whole number where we use 0. In natural number, we don't count 0, 1, 2, 3. All this is natural number. So these are some basics which are required for you to know before starting the topic. Okay, so now we will see the first thing. So there are two terms, predecessor, successor. Predecessor, successor. Predecessor क्या होता है? What is predecessor? That is, generally we read this term in terms of king. Who is the predecessor of Akbar? One generation above Akbar. That is the father of Akbar. That is Humayun. Humayun is the predecessor of Akbar. And who is the successor of Akbar? That is, after Akbar, who sat on the throne? Who got the throne? That is Jahangir. That is one generation after Akbar. So if this is a number 8 and I want to know its predecessor, then one number before this number is predecessor 7. And if I want to know the successor, one number after that number is successor. So 9 is the successor, 7 is the predecessor, and 9 is the successor. Simple thing, basic thing. Any issue? I hope not. So if this is the number 1997, I want to know the predecessor, then what I will do? One number before this 1997, that is 1996 is the predecessor. And who is the successor? For successor, what I will do? I just add 1. Successor. 1998 is the successor. Got it? So this is the story of predecessor and successor of a number. Comparing numbers. Which is the greatest and the smallest number? So if I give you two numbers, let's say for example, and I want to ask, okay, tell me which number is greater or which number is smaller. So if I give you an example, let's say the number is 42 and 52. Which number is greater and which number is smaller? You can see, very easily you can tell. Obviously 52 is greater than 42. Very easily you can tell. Because that you can tell from your intuition. But if I give you a number like this, and the number is now I want to ask which number is greater, then you might get confused. Then what to do? A very simple thing. I want to tell first if the number of digits is less. Here you can see 92. It has only 2 digits, 9 and 2. 392. It has 3 digits. So obviously the number which will be having more number of digits, that will be greater. Obviously 142 is less than 142. any day it is less than, because it has only 2 digits and it has 3 digits. Right? So I don't think there is any scope of confusion here. No. So obviously you can tell 92 and 392. 392 is greater. Again 4456, 392. So you can tell here this number has 4 digits. 92 is greater. Again 4456, 392. So you can tell here this number has 4 digits. This number has only 3 digits. So again this 4456 is greater than 392. Here it is greater than 89742. It has 5 digits and it has 4 digits. So obviously this is greater. Got it? So this was a very simple case where you can just see the number of digits and you find the answer. But if I see these kind of questions where the digits are almost similar, 1920, they have used 1920 in different permutation combinations, basically in different arrangements. Here they put 1 here they put 1 at the end, here again they put 1 at the right extremum, here they put 1 in the middle. So in these cases, even though the things are simple and you all must be aware and it would be very simple, but again I want to tell you, to find the greatest number, I'll tell you a trick, simple trick, nothing to worry. And again, my way of teaching is, I don't rely upon remembering formulas and all. Yeah, I will tell you certain formulas that are necessary to learn, and that number will be very, very minimal. Otherwise, my whole teaching will be based on concepts. So here you can see 1902, 1920. So 1902 and 1920. So this was the era of non-cooperation movement, and this was the era of partition before Swadeshi movement. So obviously you can tell 1920 is greater than 1902. But you need not to relate with history. I just told you just to have a pictographic memory. But here how you can tell you how you can solve 1902, 1920. This is a very simple example. Because there are only 4 digits, then it would be easier for you to tell without applying the logic. Yeah, 1902 is lesser than 1920, yeah, everybody knows this. But I will tell you a trick and you try to apply that thing. You start from the left extremum, you start from here and compare respective digits. Like this I will compare with this I will compare with this I will compare with this, and this I will compare with this last digit. And whosoever numbers left side will be greater, that number will be greater. I will tell you. Here 1, here also 1, both are same. I didn't find anything. 9, both are same. I didn't find anything. Here it is 0 and here it is 2. Obviously 2 is greater than 0. I started from the left. I found 2 digits that are similar, so I couldn't get any result out of this. But here when I compared 0 and 2, I found 2 is greater than 0. Then I stopped there only and I found this digit is greater than this digit. If I apply the same logic here, 9201 and 1920. I start from the left, 1, 9. So at the first instance only you found that this 9 is greater than 1, then this whole digit will be greater than this digit, this number. If I compare 9021 with this number, so I start from the left, 9, similar, 2, 0. Obviously 2 is greater than 0. So again this number is greater than this number. So you can compare all the numbers and you can find the answer. So you will do the practice for the rest of the numbers and you will arrange in a sequence. But I have told you the general idea that how to do it. Simple, nothing to worry. So if I arrange in this in sequence, then I think I'll write like this. 1902 is the smallest, then 1920, then 9021, then 9201, and then 9210. This will be the sequence, and this is the increasing order. Why increasing order? Because from here to here the number is increasing, here to here number is increasing, here to here number is increasing. Got it? And this sign, this is greater than. If I have written this B A, then where this mouth is open, that number is greater than this number. B is greater than A. Similarly, I can write B is greater than A, or again I can write B is greater than or A, or I can say A is smaller than B, because the where the face is open, A is opposite to that direction. So either B is greater than A or A is smaller than. Got it? Simple. So we are done with the comparing numbers. Okay. I also have this sheet with me. So I'm just looking for the handout, whether I'm missing anything or not. Place values. What are place values? Okay, place value is, let's say, how does a number form actually? How does a number form? Let's say there is a number 49. How does this number 49 form actually? In reality, how does this form? So this 49 is formed, this is 49, where we use the concept of place value. So this is our unit digit. This is our 10th digit. Like this, another number will be, that would be at 100th place, 100th digit, 100th place, 1000, 10,000, and like this. So this 49 is formed, here it is unit digit, so here we will write 9 into, because it is at unit place, unit means 1, 9 multiplied by 1. Then, what is the digit? 4. And this is at the 10th place, 10th place, so 4 into 10. So if I solve this is 40 plus 9, that is 49. That is how we get this number 49. Got it? If the number is 543, then this is unit digit, this is the digit at 10th place, this is digit at 100th place. Then how will I write? I will start from the left, 100th place, 5 into 100, because it is at 100th place. Then 4, this is at 10th place, 4 into 10. And then this is 3, 3 into 1. Then this is 540 plus 3, that is 540. Got it? So that is how we get these digits. So this is what it is written. This is unit place, 10th digit, 100, 1000 and 10,000. Right? So I'll solve one question and then you will do the remaining. So 68,400. So I'll start from the left. This is unit, 10th, 100th, 1000 and 10,000. So 6 into 10,000. Then 8 into, this is 1000. 1000. 4 into 100 plus, anyway you need not to do here, 0 will always be 0 if you multiply with anything, but again this 0 is at 10th place, so I will multiply by 10, and this last 0 at unit place. And if you will solve all this would be 60,000, this would be 8,000, this is 400, this is 0, this is 0, and if you will do the calculation, you will reach at this number 68,400. 68,400. So 68,400 is composed of 60,000, 8,000, 400. Got it? This is how we get this number. So that is the concept of place value. So I am not giving you any bookish definition. I am just telling you what is required in your exam. So all these little things you will use in the exam. Even there will be so many questions where you can not apply conventional methods. There you will apply optional, reverse engineering you will do. You will see the options first. In those places, these things, these little things, the command over the basics, the command over the conceptual clarity will actually work. Okay? So next, making numbers with digits. 3 digits. So, generally there are questions like, what is the greatest number formed by 3 digits? What is the smallest number formed by 3 digits? Very simple, extremely simple. You should focus upon the concepts. Let's see. I want to find the greatest number formed by 2 digits. Greatest number formed by 2 digits. So what I'll see? 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All these are single digit numbers. So here we are not talking about second digit. So this is out of our question. Because we are talking about 2 digit largest. So these two conditions should be fulfilled. Then as we moved from 9th to 10th, 9 is single digit and 10 is 2 digit number. Then till what number this 2 digit will be continuing? Think 10, 11, 12, 13, 50, 60, 70, 80, 90, 91, 92, 93, 94, 95, 96, 97, 98, 90, 900. 100 is 1003 digits. Our question is 2 digit. The 100 is out of question. Then 10 to 99 we are having 2 digits. Now let them ask whatever they want to ask. We are ready to give them the answer. What is the smallest digit that can be formed by 2 digit? 10. What is the largest number that can be formed by 2 digits? 99. Simple. Got it? Like this, if they ask 3 digit. So it is asking with repetition, without repetition. If I say this 99 is the largest number formed by 2 digits, however, here the digit 9 is repeating, 9 repeating, right? So if they ask, I want to find the number which is largest and made up of 2 digits, but the digit should not be repeating. Means if 9 has come, then the another digit should not be 9. It can be anything else. Then what will be the largest digit? 99 less than 99 is 98. Then 98 will be the largest digit, which is made up of, 98 is the largest number which is made up of 2 digits, and where these two digits are not repeating. These two are different digits. Got it? So like this, here 3 digits with repetition, that is repetition is allowed. So if repetition is allowed, then 3 digits would be 100. First 3 digit number is 100, 99, 100, 100. Then this 100 will continue till 100, 200, 300, 400, 500, 600, 700, 800, 900. So 900, 900 is also a 3 digit number. So till here we are getting 3 digits. 900, after 900 we are getting 901, 902 like this, 990, 991, 992 like this, 999 and then 1000. In 1000 is not a 3 digit number, it is a 4 digit number. So this is wrong. Then one term before 1000, that is predecessor of 1000, is 999. 999. This is the 3 digit number. If you go beyond 999, then you will get the answer as the digit as the number as 1000. Then 1000 is 4 digit number. So it is 999. So the with repetition largest digit would be 999. Because after 999, if you go, then you will find a 4 digit number. And a smallest number would be, obviously, because it starts from 100. Because if you go below 100, then you will find 99. And 99 is a 2 digit number. And my question is about 3 digit. Got it? Any problem till now? I hope it should not be. Now it is asking without repetition. Largest number. So we have the largest number as 999. But it is asking, now what is the largest number which is made up of 3 digits, but the digit should not be repeating. So if I go down. 998, 997, 998, 997. Like this, there you can see this 9 is anyway repeating. Even if you are changing the digit at the unit place, this 9 is repeating. So I'll move like this and I'll find 990. Here also 9 is repeating. Again I'll go below. 989. Here again this 9 is repeating. Then again I'll go 988. Again this 8 is repeating. Then I'll go beyond and I'll find 987. This is the first digit which is having all three discrete digits. This is the first number which is all having all the digits are discrete, different. So this is the largest, 987. And smallest number which are having different digits. So if this is 100, so 1002 is repeating, then I'll go 101. But here 1 is repeating, I'll again go 102. 102, all are different numbers. So here answer would be 102. Here it would be 987. Got it? So that is how you do you make the numbers with different digits. I hope this concept must be clear to all of you. Okay. Now they ask a question of 4 digit. So should I need to do this question or you will do it on your own? Okay, I'll solve it, but very rapidly. So with repetition. So 4 digit, 999. After 999, 1000. 1000 will be the first 4 digit, and this will go up to 9999. And there is one more way to find the largest digit and the smallest digit. Let's say they ask 4 digit. So you make 4 largest for largest. That is a trick, but I have explained you the logic. You just place 9 everywhere. 9, 9, 9, 9. Right? And if for the smallest number, what you will do, 4 digit, you will start from the right, 0, and start placing 0, 0, 0, 0, and at the last place you will put 1. So that is the smallest 4 digit number, 1000. I can use this in 3 digit. Let's say 3 digit. Largest. For largest, what I'll do, I'll make this 3 and I'll place 999. For smallest, what I'll do, I'll make 3 place, I'll 0, 0 here, I'll put 1. 100, 999. But this concept should be clear, right? Because these tricks are okay, but you need to understand the concept behind these, how I am placing this number. Okay. So if I'll 4 digit is 4 digit is 1000 to 9999. Largest number will be 9999. With repetition, the smallest will be 1000. And without repetition, how you will do? 9999. Largest number. So what you will do? When a number will be largest, when the last extremum is the greatest. This should be greatest, 9. And a number is largest, I told you earlier, while going from left to right, you compare the numbers, right? So if this is 9, then I cannot use 9 here, because if I use 9 here, then the digits will be repeating. Then what I will do? I'll place 8, 9, 8. Then I'll put 7, then I'll put 6. 9, 8, 7, 6. This will be the greatest number that is made up of 4 digits, but without the repetition of any digit. Did you get it? How? From left we do it. For largest, the left should be greatest. Left should be greatest. And here it should be smallest. 876. 876. Okay? And for smallest, what I will do? Smallest, if you put this number greatest, if you put this as 9, what is the greatest number? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the greatest. If I put 9 here, this will be the largest digit. So for smallest, I'll put here 1. I cannot put 0. Because if I put 0, then let's say digit is 0, 2, 3, 4. So actually it is not a number made of 4 digits because 0 is not counted here. We will write it as 2, 3, 4. This is only a 3-digit number, right? So you cannot put 0 here. 0 doesn't have any meaning if it is written at the left extremum of any number. Got it? So this is 0, 2, 3, 4 or 2, 3, 4 is similar. So I wrote 1 here. Now, if I put 8 here, this would be greatest, because if I, let's say I put 8 here, 8 some any number, let's say 2, 3, and I'll compare it is 1, 2, 2, 3. So if I come from left side, this 8 is greater than 2, then this number becomes greater. I don't want a greater number, I want a smaller number. Then for the smaller number, what I'll do? For a smaller number, what I'll do? For a smaller number, I'll write 1, then the next smallest number. 1 I used already for not repeating the digit. What I'll do? I'll write 2, the next smallest number, the next smallest number, the next smallest number, and 1, 2, 3, 4 will be the number which is the smallest number made up of 4 digits, but the digits are not repeating. That is the condition. Got it? So I hope it is clear. And here we made a very minute mistake. That is why I am asking you. That is, here we made the mistake. Because when we used 1 here, then the next smallest digit will not be 2. We can use 0 here, yeah? 0 we cannot use here, but here we can use 0. And then the next smallest digit would be 0 and 1 are already used, then 2 and then 3. Then 1, 0, 2, 3 will be smallest, not this digit. Got it? So this is the smallest digit, made up of 4 digits without repetition of digits. Got it? So knowingly I have used this just to show that how you can make the mistake, how you do mistakes in the exams. But I hope everything is clear, and after these sessions you will not be doing silly mistakes. So whatever silly mistakes you are going to do in the exam, do in your home, do while practicing, do in the class, not in the exam, because that can cost you 1 more year of your life. What 1 more, 2 more years of your life, right? Okay. So then 5 digits, you do it on your own. I have explained you for 4, 5 and 6, you will do it on your own. Now it is asking making numbers with digits with repetition. So if I want to make the largest number out of 2, that is there are 4 digits with repetition. Repetition is allowed. So at the left extremum, maximum number you will place 2, 8, 7, 4. That is 8 is the largest, so you will put 8 here. And repetition is allowed. So all the digits you can use 8. So this will be the greatest greatest number formed out of these digits where repetition is allowed. And the smallest number is, you will choose the smallest number 2, and everywhere you use this one. That is the smallest digit, right? Without repetition, again, now this question is without repetition. So for the largest number, the left extremum should be largest. So here you put 8, then you don't want to repeat the number, and you want the greatest number, then here will be the next greatest number after 8. So it is 7, then 4 and 2, and for the smallest, there will be the smallest number 2, because if you put the greatest number, you will find the largest number. For the smallest number, you will put the smallest number here, 2, then 4, then the next 7, and then the largest number at the end. These 2 are the answers for our question. Very general thing, very simple. You will do the practice and you will get it very easily. And even if you have any doubt, you can ask me. Okay, so we'll see next. Again, 4750. Repetition is allowed. So what I will use, I will do 7777. And a smallest number with repetition. So I cannot use 0, 0, 0, 0 because 0, 0, 0, 0 will be 0. That is a single digit number, right? So, but I want to use all this. Then what would be the smallest number? I can use this smallest 4, then 0, then 5, then 7. Because 4, because if you put 0 here, then there will be only 3 digits. 0 will not be used, and I want to use 0, so I will and with repetition, sorry, if you want to use with repetition, don't know what I'll do. I'll just put the smallest number 4 and I'll just use all zeros. 4, 0, 0, the smallest number, and I'll repeat all this. Because if you write all this 0, 0, 0, this is not a number, this is 0, 0, only 0. And this is single digit number. For 4 digits, what I'll do, the smallest number here, and then the next smallest number after this, 0, 0, 0, 0, 0. Because even if you write 0, 0, 0, 4, then this is only a unit digit number because it is equivalent to 4. This is a single digit number, that is only 4. But I want to make a 4 digit number. Without repetition, obviously you will do largest, next is smaller than that, then is smaller than that. And the smallest number, I will use the smallest number here. But again, I cannot use 0 because if I use 0 here, then the digit will be formed, number will be formed of a 3 digit. Then I will use first 4, then 0, then next, and then the greatest number. That is the number without the repetition. Got it? Simple? Okay. So now we want to know the prime numbers. What is a prime number? Prime number is a number which gets divided only by two numbers. Which gets divided completely only by two numbers. First is 1, 1 se divide, and second is divide by itself. Let's say I take a number 11. So there is no number which can divide 11 except 2, either 1 or 11 itself. No other number apart from these two numbers can divide 11 completely. Okay, so that is prime number. You cannot divide prime number by any other number except 1 or that number itself. 5. 5 can be divided only by 1 or 5 itself. You need to remember the prime numbers from 1 to 100. So I'll just tick mark the numbers 1, 3, 5, 7, 11, 13, 19, 29. This is the prime number till 50. And till 100, I'll just tell you. Anyway, 100, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. Right? I'm just cross checking if I have left any number. I don't think I have left any number. So all these numbers are there which are the prime numbers which can be divided only by 1 and by that number itself. So now it is prime factorization, to factor a number. What is factor? Factor is, let's say, the factors of a numbers are, if we multiply those numbers in it, with each other, then we find this number. That is the factor. So how will I find the factor? So for factor, I will tell you some 2-3 basic things. You need to know the divisibility rule. of 2, 3, 6, 5. Other 7, 11, 13 I'll tell you later. But for this class, these 4 will be sufficient. So for 2, if at the unit place of any number, if the digit is even, then the number will be divisible by 2. For example, let's say a number 480. So I'll just see the unit digit 0. 0 is an even number. What is even number? 0, 2, 4, 6, 8 are even numbers. What is odd? 1, 3, 5, 7. These are odd numbers. So 480. Unit place number is even. Then it is divisible by 2. Let's say 7, 6, 4, 5, 2. Whatever number they give you, whether it is a big number or a smaller number, you just see the unit digit. 2. 2 is an even number. Yes, it is divided by 2. 3. The sum of digits of the number should be divisible by 3. Let's say I want to get whether this number is divisible by 3 or not. Then what I'll do, I'll find the sum of the digits. 4 plus 8 plus 0, that is 12. If whether 12 is divisible by 3 or not, yes, 12 by 3, 4, 3 into 4, 12, completely divisible. Then this number is divisible by 3 also. Let's say I give you a number 561. Let's say I give you 562. To know whether it is divisible by 3 or not, I'll add 5 plus 6 plus 2, that is 13. And 13 is not divisible by 3. Then this whole number will not be divisible by 3. Got it? So this is about divisibility of 3. If you understand divisibility by 2 and 3, then 6 will be a cakewalk. A number which is divisible by both 2 and 3, that will be divisible by 6. Got it? So if there is a number and I asked that, okay, tell me whether this number is divisible by 6 or not. So what will you do? You will apply the divisibility rule of 2 and 3, and if you find that the number is divisible by 2 and 3 both, then the number is divisible by 6. Otherwise, this number is not divisible by 6. And this 5 is the unit digit, the digit at the unit place will be either 0 or 5. Then the number will be divisible by 5. That's the number is 420. This is divisible by 5. 421. Unit digit is 1. It is not 0 or 5. Then this will not be divisible by 5. 425. Unit place digit is 5. The number is divisible by 5. Okay? So if you have this basic idea, then we can do the factorization very easily. Why it is called prime factorization? Because prime number cannot be divisible by further. Like it cannot be divisible by any other number. Let's say if this is 6. So you can see 6 is not a prime number because it can be divisible by 2 and 3. So it can be written, it can be further broken, 2 into 3. But if it is 7 written, then you cannot break 7. This is a full-fledged factor. It cannot be broken further. So when it cannot be broken further, that is called prime. And the factor is called prime factor. And this process is called prime factorization. So now we will see the prime factorization, how to do the factorization. And believe me, this factorization becomes very handy. It comes again and again while solving the questions of quant. So you need to have a grasp of this factorization. Okay, so we will do this, the factorization of 60. So we will do the prime factorization of 60. So how do we do that? So you find the least prime number which can divide this number. So you can see 60, unit digit is 0. Then it can be divisible by, it is divisible by 2. So what I'll do, I'll draw a vertical line, then I'll draw a horizontal line. And I'll write the number here, 2. Because 2 can divide this 60 and 2 is the least prime number. What are the prime numbers? 2, 3, 5, 7, 11. So you will start checking from here 2. If it is not divisible by 2, then you will check 3. If not 3, then 5, then 7, and like this. So 2, 30. 2 and 60 by 2, 30. Now, this is your target, 60, 30. Then this 30 is again divisible by 2. Then I'll write 2 and I'll divide 30 by 2, 15. Now my target is 15. This 15, whether it is divisible by 2, the unit digit is not even. So it is not divisible by 2. Then 3. The sum of digits of 15 is 1 plus 5, that is 6. And 6 is divisible by 3. Then this 15 can also be divisible by 3. So 3, 5. Then this 5 cannot be divided by 2 or 3. But 5 can be divided by 5. That number itself, 5. And you do that exercise till you get a number here, 1. Right? And you take all these 2 into 2 into 3 into 5. 2 into 2 into 3 into 5. So this is the prime factors of 60, because if you will multiply all this, 2 into 2 4 into 3 12 into 5 60, you get 60. So the prime factors of 60 is 2 2 3 5. Got it? Now we will do for 75. So this is very important. 75. Again, this is not divisible by 2. I'll check for 3. 7 plus 5, 12. 12 is divisible by 3. So yes, 3, 25. 25 is not divisible by 2 or 3. Then it can be divided by 5, because unit digit is 5. 5. Then again 5. Then the prime factors are 3, 5, 5. And if you multiply all this, you'll get 75. 3 into 5, 15 into 5, 75. Let's say now these two you will do. I'll do the last one, 968. 968. Unit digit is even. So I'll divide by 2. Again 2. Again unit digit is even. So again it can be divided by 2. Now I have the prime numbers as 2, 3, 5, 7, 11, 13 and like this. The unit digit is not even, so it cannot be divided by 2. So I will not write 2 here. I will again draw a line. 3, 2 plus 1, 3 plus 1, 4. 4 cannot be divided by 3. So it cannot be divided by 3 also. The unit digit is not 0 or 5, so it cannot be divided by 5. 7. So if I divide 121 by 7, it is not completely divisible. No. Then 121 is divisible by 11. Because 11th square is 121. Then this is 11. And then again 11. This is 1. Got it? So the prime factors will be 2 into 2 into 2 into 11 into 11. Got it? Simple. So this is prime factorization. You need to remember the squares till 30 and cubes till 20. At least till 10 you need to remember the cubes, and squares you need to remember till 30. And if you know the square of 11, that 11 square is 121, then very easily you can just write 11 here. 11 will be divided by 11, then again 11, 11, 11 into 11 into 2 into 2 into 2. Got it? Sure. Next. Now fractions. I'll do the fractions. So fractions, how will I do it? So let's say there is a number. This is numerator. This is denominator. Let's say number is 3 by 4. Then 3 is numerator and 4 is denominator. It is said that if denominator is greater than numerator, this denominator is greater than numerator, which is happening in this case, then it is a proper fraction. Because denominator is greater than numerator. And where 5 by